Good morning, and we're back. Hello? Okay, I said I'd like to start on time, and I'm a minute late, which we're still technically about 19 minutes ahead of schedule, according to the agenda. So welcome back, and thanks for taking your seats. I gotta tell you, as compared to when I've emceed other events, this was really fast, like amazingly so. The International Regulators Forum, we were walking around and I felt like I needed sticks to poke people and get people to their seats, so thanks for that. So there have been a couple of questions. I'm gonna do a little bit of bookkeeping and then we're gonna get into our second panel. So we will conclude probably a little bit early unless people have a lot of questions. So that's good news since we're going right through your lunch hour. Please hang in there. And hopefully if you do get hungry, just pop downstairs for a snack and come back up. Questions have arisen about whether or not this is live webcast. Well, it is not live webcast right now, but it will be available. I can't say exactly how long, maybe a couple of weeks it will take us because part of what we like to do is, as you can see, is we like to be accessible to everyone. And so this will be up on our website with a transcript or with subtitles within, I'm looking in the back, 2 weeks, he says. So what we'll do is we'll push out a notice through our website and perhaps to the broader community of people who attended today to let you all know that it's available for viewing on our website. So one other thing that's kind of a reminder is we've been using the term bolts pretty loosely here. So just to remind everybody, in case anyone came a little bit later, when we say bolts, we mean fasteners, we need connectors, studs, the whole collective of things. So you may hear people say these things interchangeably, but the word bolt actually is kind of ambiguous in how we're using that. So I'm Allison Anderson. Is that up here? Yes, it is. Okay, I am the Associate Director at BSEE, and I will be moderating this panel. You don't get the benefit of bio, and frankly, you don't need it, because I think I know about 80% of the people in the room. So welcome back. So now with the rest of our panel, what we're going to be talking about is looking at maybe what the gaps are and what's next as we framed it in the agenda. And so the panelists that you have here have, if you notice, there's a pretty diverse group of people, but since you don't have the benefits of their full bios, I'm going to kind of give you a look ahead. Many of you know Eric Melito. I'm going to go from Eric on down. Trent Fleece, and then we have Jack McHale, Jim Lancaster, and then Jaime Zhang. So just to briefly introduce each person, and then we'll let people come up and do their presentations in order, and I'll just sit in the audience since that's full. So Eric Melito and Trent are sort of a team for representing API and industry today, and so I think Eric is going to be doing the presentation. But for those of you who don't have the good fortune of knowing Eric, he's the API Group Director for the upstream and industry operations, and he's been at API for quite some time. But what I find most interesting about Eric is that prior to joining API, he had a deep and rich career with the US Army, if it's okay that I mention that. And I thought that's one of the more awesome parts of what you've done in your life. Also, he's been an attorney in our solicitor's office in the Wayback Machine at DOI. And so he's familiar to many people here. Trent Fleece is, I would like to say, the guru of BOPs on this panel in particular. So he's coming from BP, and he's been their team lead for BOP operations, I think, for a little bit of time now, but he's worked there for about 18 years. And he is a licensed professional electrical engineer. Okay, so that's your first set of speakers this morning. Next, we will have Jack McHale. Now, Jack is a part, hopefully, of our interagency team, and he's representing the NRC. And we invited Jack today because the NRC's had a really interesting set of issues with bolts in some of their nuclear facilities. And while they're of a different type of bolt and used in a different way, what we can learn from the interagencies is about how they've looked at addressing the problem, and many of the topics that Candy brought up in her presentation earlier are things that they considered in their analysis of their bolt issues. And so Jack is very, very accomplished in his field, and he has also some great experience in the U.S. Navy, and he was working in the submarine office there. I think you were a submarine officer, right, in the Navy. But throughout all of his time at the NRC, he's had a variety of roles that he may speak to you about when we get to him. Dr. James Lancaster is the Director of National Materials and Manufacturing Boards. So there is his relevance here. He brings some of the metallurgical and background to our discussion today, and he would be someone who would normally speak about what we're doing with the National Academies, but we've been asked to not give too much there until the contract is awarded. So he's going to speak more generally about how the National Academies tackles issues such as this one that we're discussing today. And notably, he has a PhD in physics and he's a lawyer, which is a dangerous combination. So the last panelist that we have is Jaime Zhang, and she came to us from Lawrence Berkeley Lab, and she's a part of a project that I believe we're working on between BSEE and LBNL, and is going to speak to that today. She's adjunct faculty at the University of California at Berkeley, and suffice it to say, she is very accomplished in her field. The one thing I'm pulling out here is that she won the LBNL Director's Award for Exceptional Scientific Achievement, and her background area is in a lot of material science and metallurgy as well. So she'll be speaking a little bit about what they're going to be doing in concert with BSEE. And so I'll turn it over to Eric to get started, but the general format here is they'll have their presentations for 10 to 15 minutes, and then hopefully at the end we'll get back together and people will have questions. So let's have some questions ready, and hopefully we can make this a little bit more of a lively discussion. So with that, I'll turn it over to you.
Thank you, Allison. I'd like to thank Director Salerno and Assistant Secretary Janice Schneider for inviting API to come and participate in this very important event. We as the industry really look at safety as a core value, and we want to make sure that it's clear that we're also here to collaborate in these efforts, and we appreciate the collaboration to date, and we look forward to continued collaboration. I think in order to help set the stage and to help communicate how API is involved with this, it's important to have some background on API, and I'm going to take you back a little bit far to 1919 when API was originally formed. We started after World War I as a standards developing organization. We realized due to the war efforts, there was a lack of consistency in the industry when it came to the standards and the materials that were used in the oil fields, and we were developed as a standards developing organization. Now looking forward to today, we have 685 standards, and we have 7,000 volunteers around the world working on these documents, and these are the experts in their fields, and we follow a process that is accredited by the American National Standards Institute, and it requires that there is a balance of participants in the development of a standard, that there's a consensus, that there's due process, and that we do bring together a lot of these parties that we hear about today, the equipment manufacturers, the drilling contractors, the operators, academia, and BSEE representatives. It's important that we have the government involved in this process because these documents really are the foundation of system reliability, system integrity, and a total system of safety. Now, if you think about these documents, they are utilized around the world. They're most cited standards globally, and in the U.S. offshore, over 100 of our documents are incorporated by reference into the regulations. So we see it as a true effort of collaboration because the regulator is able to take our documents and make them a requirement by putting them into the regulations. We also have, and in order to kind of describe the type of documents we have, some of you know a lot about this, a lot of the industry people are in here, but I think it's important to lay this out. We have a standard, it's called a specification. That's one of the key documents you hear about a lot today. A specification is a document that governs the design, manufacturing, and testing of oil field materials and equipment. So we have a lot of documents like that in the offshore and in exploration and production as a whole. We have well over 200 documents in our portfolio that relate to exploration and production. Then we have recommended practices which govern how a company operates, how a company drills a well, how a company fractures and stimulates an onshore shale well. Lots of documents are recommended practices. And then we have a standard that's called a standard. Standard takes a combination of a specification and a recommended practice, sometimes elevates it by creating terms in there that make it more prescriptive or more mandatory the way you look at the document. And then we have bulletins and then our guidance documents. But we have this whole suite of documents that we continually develop. And we have a requirement for us to relook at these documents every 5 years and to revise them so that we're keeping up with the times. Lots of committees. The committee that we have in place is the Committee on Standardization of Oilfield Equipment and Materials. Lots of subcommittees that report to that committee. So we have subcommittees on materials, quality, subsea equipment, BOPs, lots of different subcommittees working day to day, and they're volunteers in this industry who are coming forward to make all this happen. This is all important in the context of what we're talking about today because we have bolting specifications and we have BOP standards and we have flange documents and valve documents all relate and work together to enhance the overall system safety. In addition to that, what complements all this is the API monogram program. So we have a specification, Q1, which is a quality management system document for manufacturers. And a manufacturer of equipment, a manufacturer of a bolt, is in a position to be able to come to API and go through an audit and certification program so that they receive the monogram and they can put it on their product, and it shows that they have gone through the audits and the requirements necessary to demonstrate that they can manufacture that equipment under the quality assurance and quality control guidelines of the API Q1 standard. So that's a very neat complement. If you think about the comments that we heard today from Dr. McNutt, she talked about, okay, what are the requirements and what are the standards and how can we certify against those? So we have a system in place that we look to and that we rely on to have a specification, have the design requirements, the materials requirements, and we have a certification program in place as well. So that's the backdrop that I like to give to you before I get into the overall presentation on what we've been doing as API and what we've been doing as an industry. And it's not just API, it's API working with the broader industry to make sure that we are communicating our work on the bolt issue, not just here in the U.S., but the work we do, I believe, is going to have an impact globally. We've heard a lot about how we need to make sure we're not focusing just in the Gulf of Mexico, and we represent global companies who operate around the world, and they take this information and disseminate it around their operations around the world. So we believe we have a holistic approach that we're taking to proactively address this bolt issue. So what we're going to do is give you an overview and share with you the work that we've been doing. The second bullet, I think, is important because we have two work streams that you see at the bottom. We had the multi-segment task group that was organized shortly after the release of the August 2014 QC FIT report. And then we have a working group that we put together after the safety alert earlier this year. But the significance there is that we've brought together operators, rig contractors, and the equipment manufacturers to work collaboratively together and to have all that expertise there. Many of them are in this room, and these are people that I think BSEE, National Labs, anyone involved in this can rely upon because they're out there day to day, and it's their job to enhance safety. It's their job day to day to focus on that core value of safety, and that's who we rely on as API. It's the experts. We've also been collaboratively engaged with BSEE. Shortly after that QC FIT report came out, we asked for a presentation on it. We'll get into that in a little bit, and then we're committed to that moving forward with all the stakeholders in the room. Now, this is a busy flow chart. It's a busy timeline. And I'd like to point out that API's work on bolts actually started well before that, well before this timeline even starts. And I'll talk about that when we talk about the specifications that we have specific to bolts. But the QC FIT report came out in August of 2014. When it came out, we talked to BSEE and said, well, can you present to us on it? We have semi-annual standards committee meetings, and we had a presentation from BSEE on that, I believe, in the December standards meeting, and then that's the first time we had the opportunity to hear about this concern and the significance of this issue from the regulator. Shortly after that, we put together the multi-segment task group, which had at least a couple dozen experts participating in that group. And they were looking at this from the standpoint of, one, identifying the potential failure mechanisms related to bolts and the equipment associated with bolts. Two, identify the contributing factors around those failure mechanisms. Three is to then look and identify the mitigations in place, the API standards, the ASTM standards, the regulations, the equipment. What processes and what standards and protocols do we rely on currently at that point that mitigate against the potential risks that we've been talking about here today? And then finally, to make recommendations that fill any gaps and to enhance and improve the overall system of mitigating against those risks. And they looked at the same factors that we heard Dr. Hudson talk about. We're looking at materials, we're looking at design, we're looking at stress, we're looking at external environments, and we'll get into that as well. So by the end of the year, we've had dozens of meetings, bi-monthly meetings of the multi-segment task group, and then we provided a report with 20 recommendations related to various aspects of API standards, as well as those conflicts that might be out there between the ASTM documents and the API documents. What kind of research do we need to do? Do we need to look at the design factors, the material factors? So we then put to work all these standard subcommittees on materials, on blowout preventers, on subsea equipment, on quality, and they're now implementing the recommendations. So this is really the focus on the API technical programs, our standards, our quality programs, making sure that we have that feedback loop of continuous improvement to make sure that we're addressing and enhancing everything related to bolts. March, the safety alert comes out with recommendations into it. Trent has been chairing that work group of 50-plus experts developing the ways and the path forward to operationalize ways to enhance operations. And the meetings that occurred there were in BSEE in March and in June, and we provided a letter in July that laid out our path forward, and we received a positive response from BSEE in that, based upon what we know now, we really believe we have a holistic approach in place to address all the factors and make sure that we are operating in a way that mitigates the risk as great as possible. As we move forward, we obviously want to make sure that we continue that collaboration that we need between industry and the government, and as we move forward this year, continued workshops between the technical representatives, folks like Trent and a lot of people in this room, and the BSEE technical folks here in Washington and in the regions and the district level is going to be key to making sure we do this in a fit-for-purpose, practical, and overall safe way. So we've focused on 4 areas: research. We have standards committees that are implementing research on things like hydrogen embrittlement and corrosion-resistant alloys. Our standards, I'm going to talk specifically about those in a sec, but we are continuing to look at those, review them, revise them, and consider the changes that need to be across the board, because they all interrelate and they normatively reference each other. So you've got the BOP standards, the flange standards, the quality management system standards. They all relate in the overall system that we rely upon, and we're looking at all those. The quality assurance, quality control, that's the Q1 monogram program that we have. We continue to look at that to see if there are areas that we need to address when we go out and do audits and we certify manufacturers. Are there gaps that we're looking at? And then we have a feedback loop there as well that takes the information from those audits, from those certifications, that is able to go back into the standard setting committees. And we have a committee that oversees the monogram certification program. That feedback loop plugs all that information back there as well. And then, as I mentioned, we've proactively put together the work groups to address both the long-term technical program developments and enhancements that need to occur, as well as what we need to do to operationalize the work out in the field. So the specifications, and this is where I mentioned that the work actually began prior to the QC fit report in August on that timeline that I showed you, but Specification 20E is a specification specific to bolting. It's the alloy and carbon steel bolting for use in the petroleum and natural gas industry specification, and it hits on all the issues that we've been talking about when it comes to materials. So that came out in 2012. After that committee finished this document, that committee went to work on 20F, which is the specification on corrosion-resistant bolting for use in the petroleum and natural gas industries. So well before we were aware of the significance of the bolting failures as BSEE has raised them, we had committees that were proactively developing specifications for the bolts used in offshore and subsea operations. Ellison mentioned, what are we talking about here? Well, the documents actually define what a bolt is for purposes of these standards, and you can see that it includes all thread studs, tap end studs, double-ended studs, headed bolts, cap screws, screws, and nuts. So it's a large population of fasteners and connectors that are used in the offshore that we're talking about. And the topics covered by these specifications are diverse and are intended to make sure that we have materials in place that will withstand the operations and the conditions that we see in the deep waters of the Gulf of Mexico. Now, when you look at it from the factor standpoint, which factors are we looking at? Dr. Hudson referenced the circles that Trent developed, but we look at it from a material resistance standpoint, a stress standpoint, and a subsea environment standpoint to make sure we're covering really all the bases as we address this issue. And we have some examples up there. Material resistance, do we have the materials in place so that we are mitigating against the risks and potential failures? We believe that we have these standards and these specifications in place with 20E and 20F that are designed to make sure we have those types of materials in place. On the stress side, it's the design of your offshore system that you have in place, your blowout preventer system, as well as the way you apply and put in place the bolts, the torquing that we've heard a lot about, in the subsea environment. Are we looking at what factors the external environment presents that could impact those bolts that are in place? And are we investigating and minimizing the consequences that can occur and create environmental cracking, which is what we don't want to see at all. And so we look at things like hydrogen sources. So this is the way that the multi-segment task force has looked at this, and the working group, to make sure that we're really covering all facets of operations, materials, design, external environment, to have that full system of safety that is the ultimate objective. And here's our overall summary of the actions that we have taken. We've engaged the experts. We've developed the multi-segment task group report with the recommendations for the standards and the technical programs, and not just for API, but for organizations like ASTM, so that we have the consistency we need. And then we've established the work group to provide the recommended path forward. And those recommendations include something as simple as defining critical bolting. What bolts are we talking about that we really need to make sure we're addressing? And we define that as bolting that the failure of which could result in loss of containment of wellbore fluids to the environment. So that's the focus of the recommendations. And then we have the standards in place. They're relatively new, 2012, 2015. We have increased adoption of those specifications. We have upgrading of bolting as the BOPs are being maintained and swapped out. We've heard a lot about some of the OEMs doing recalls, so we see the exchange of bolts to the 20E, 20F type specified bolts. Enhanced quality assurance, quality control. Now that these documents are out, the original equipment manufacturers can go through the API monogram program to get that certification to show that they're designing and manufacturing their bolts according to API spec. updated makeup procedures with additional engineering rigor and oversight, looking at things like torque and other aspects of operations, looking at the bolts during spot checks, when you're pulling the BOP during those phases of operations, elimination of electroplated zinc coatings. That goes back to the original February multi-segment task group recommendations. That was one of their recommendations, and we're carrying through with that. And enhanced failure reporting. One thing that's happening globally is that the International Oil and Gas Producers Association has a joint industry project in place where they're collecting BOP reliability data. So we have that going on as we speak, along with the additional reporting requirements are now in the well control rule. So we view this as a holistic approach moving forward that addresses all those elements that we've talked about, and this nicely complements the technical work that is ongoing. One thing I'd like to talk about quickly here is we heard Dr. McNutt also talk about how Admiral Rickman came up with a robust safety system for submarines. Well, back in 2011, the industry actually created the Center for Offshore Safety, which we believe is a robust system for offshore operations. The Center for Offshore Safety has a focus on safety and environmental management systems, and they look at things like management of change, hazards identification, mitigating against those risks posed by hazards. So we have a barrier in place through a SEMS program, and now we have the regulator, BSEE, requiring that, and requiring audits against that, and requiring companies to go out and demonstrate that they not only have a SEMS in place, but it meets the associated rigor that is needed to have safe operations. I point that out because we often talk about something like bolts, but we as an industry like to look at that as part of an overall system of safety, and that is what is incorporated through safety and environmental management systems that are promoted through the Center for Offshore Safety as well as the BSEE regulations. And we have our own Charlie Williams, which, I don't know, maybe he's a modern-day Admiral Rickman, but he's doing good work there and helping to promote a culture of safety. And what we're trying to do is make sure that we have that total system reliability, system integrity, and total system of safety through all the efforts that we're doing, and that we have an industry here that stands committed to effectively addressing this bolt issue through research, standards and technical programs, quality assurance, quality control, and continued collaboration with BSEE and all the folks in this room. So thank you, and look forward to any questions you might have.
Okay, and good morning. My name is Jack McHale with the Nuclear Regulatory Commission, and again, I thank BSEE for the invitation to come and speak about an issue that we've been dealing with. Now, this will be the part of the program that's now for something completely different, because when I heard 3-inch diameter, 16-inch bolts, I'm talking about a bunch of little bolts that are about the size of my pinky. But I'll go ahead and show you that. Most of the presentation here is really just kind of some pictures of where these things are installed to give some context to the application, but also I think they're things that we've heard discussed this morning as far as quality control, in-service inspection, the regimen as far as installation procedures and all that. The nuclear industry certainly deals with a lot of those issues, so hopefully there will be some parallels for that. So again, these bolts that I'm going to talk about, the Baffle-former bolts, are something that are subject of industry aging management programs. Again, they're in a nuclear reactor, and they have the unique feature, again, the service environment is probably, except for one thing, very mild compared to what we've been hearing about, that's in very pure water. The external, the pressure, temperature environment on these bolts is maybe during a 2,200 PSI vessel, and it's about 600 degrees Fahrenheit in there, and the plates that they're holding in place have maybe about a 30, not any zeros after that, pounds per square inch differential pressure across it. So loads are fairly, mild, but they're being bombarded by neutron radiation from the reactor core through their whole life. So as this fluence accumulates over the first 40 years of reactor license time, leads to embrittlement and issues. So again, because of that, these bolts were actually flagged as an aging management primary inspection component. In other words, knowing that this phenomenon with the radiation-induced embrittlement was going on, these bolts were planned to be inspected sometime around the 40-year lifetime in the reactor. And there's a couple things that you may hear. There's 40 calendar years is a standard initial licensing period for a reactor, but the inspection of these bolts is actually based on a 25 to 35 effective full power years of operation. So in other words, if the reactor is at 100% power for 1 year, that's one effective full power year. So about 32 effective full power years tends to be around 40 calendar years with the outages for refueling and other things. So again, just to contrast those two little scales there. So the reason this got our attention is that, again, although this mechanism was known and there was actually some experience back in Europe in the late 1980s that showed that some of these bolts were subject to failure, we had two reactor units this year during their refueling outages that discovered a lot larger than the expected number of bolts that were failed. Again, these refueling outages take place about once every 18 to 24 months, and again, the fuel's removed from the reactor vessel, and I'll show you a picture of that. And during that, they discovered more degradation of these bolts than had been found. Although it wasn't a substantial safety concern, it certainly got the NRC's and the industry's attention. So what are we talking about as far as these bolts? Again, the Baffle-former bolts hold together a baffle assembly, and the core where the fuel sits in a pressurized water reactor is in this purple area here. And it's surrounded by a baffle assembly, and really all that baffle does is direct the cooling flow up through the fuel. So here's an inlet nozzle. The fuel comes in, comes down outside around this core barrel, and then comes up through the bottom, and these baffles more or less direct it up through the fuel, goes out the outlet nozzle and goes off to make steam to run turbines. So because of this, configuration here, it really comes down to fitting square pegs in a round hole. The reactor vessel is a big barrel, and the fuel assemblies are square pegs, and I have a picture to show you later. So this baffle assembly conforms the square pegs to fit in the barrel. And the way this is constructed here is shown pretty well on this side. These red plates here are the baffle plates, and there are 8 levels of these former plates where you can see coming up the side here, 8 steps. And the bolts we're talking about are here at the face of the plates that actually bolt those baffle plates to the former plates. And again, directs the coolant up through the core. And the other thing is that it really tightly packs everything in there. So if there was a seismic event, everything pretty much is restrained. And also, if you were to have an external coolant pipe break, that could put some jet forces. The flow out the break would put some differential pressures across the core, and you want that all to be restrained. So that's what these assemblies do. Okay, move on to another picture. Now this is just a picture of what the bolts actually look like and how they're set in there. Again, this is just an arc of that barrel, and this step thing here is one of the former plates. And the baffle plates are just bolted to the face the edge of that former plate with these bolts, and those are the baffle-former bolts. They're about, and depending on the reactor design, there's somewhere between about 728 and 1,088 of those baffle-former bolts in a pressurized water reactor. And because of that large number of bolts, you can actually tolerate a fair number of failures. There's analyses that the manufacturers have done, and you could have perhaps 30 to 50% of those bolts that have with failures and not impact the overall structural integrity. But that kind of assumes a uniform distribution of the failures. So if you have clustering, in other words, if they start to fail in one area, that becomes a little more problematic as far as the structure, to the point where you could have maybe one of those plates detach, which would potentially then impact the fuel assemblies that are next to that, and that's something that we want to avoid. So again, just to show you the construction, these bolts are just hex head bolts, and there's some variety in the designs of these. This one's got an internal hex on it, and it has a locking bar just tack welded across it so that it's restrained. And again, these bolts are about 5/8 of an inch in diameter, about 2 inches long. They're stainless steel. They're a grade or type 304, 316, or 347 stainless steel. And the 347 bolts have been the ones that have been the most problematic in the recent experience. Okay, again, here's a picture of. This is not a real reactor because there's a ladder down there in the corner. This is a mock-up at one of the vendor's facilities. But again, you can see the fuel assemblies, and there are all these little square spots on the bottom. There'll be a fuel assembly sitting in each one of those. So again, we're fitting the square pegs in the round hole. And again, the baffle plates are these plates here, and all these little rows that you see are the heads of the baffle-former bolts. So what did they see when a couple of our utilities went in for inspections? Again, during the refueling outage, the fuel's removed from the vessel, so it exposes the sides of the plates. And in some cases, like on the left here, you can see that the head of the bolt's missing. So the whole locking bar that I showed had broken off, and the bolt head was actually missing. And then in other cases, one of the tack welds might be broken. It's a little tough to see, and you can see that that head of the bolt is no longer flush with the plate. It starts to protrude. So again, it shows that something's happened to the bolt. So some visual indications were the first indication of a problem with these. Another thing to mention is that the bolts are actually inspected for the aging management program. There's a requirement to do 100% inspection of the bolts, and it uses an ultrasonic method. So there's a probe that's developed to fit over that hex head and locking bar, and each of the bolts gets a signal sent down it and comes back with an indication. And the ultrasonic method is a go, no-go type of check. Any indication is treated as a cracked bolt, a through cracked bolt, even though the crack could just be a small fraction of the way through. And in fact, in the plants that did come up with a larger than expected fraction of bolts that were broken, most of them were on the order of 60 to 70% were still intact, so they had to be torqued to be removed. But again, it shows that there was a start of some type of cracking going on there. The other thing that the industry does is if there's for some reason that a bolt is unable to be inspected because you can't get the probe around the locking bar or something, they count it in the failed population. So it's a very conservative method, but again, and one of the things I'll talk a little bit about later is there is some thought about maybe trying to refine the technique to size cracks, and also that we're not over-predicting failures. So in the past, the experience has been that the plants that have done these inspections have found less than 10% of the bolts cracked. Some plants found 0 out of 800 and some bolts cracked, or 1 or 2 bolts out of 1,000. So again, very low failure rate. And then what was the new discovery this year is that, again, a couple of the plants had around 25% of the bolts with indication. So 25% potentially degraded, which is definitely an outlier. So what type of cracking is there? It's been known that the mechanism for this is irradiation-assisted stress corrosion cracking, and the bolt failures have occurred at the transition between. My pointer's not working, but you can see at the head to the shank region. The new bolts that are being installed have an improved transition there. This one actually is not too bad because you can see it's got the curved contours. Some of the bolts are very stepped. It's like a notch almost between the head and the shank, which is obviously a stress riser. So the replacement bolts are more with that filleted head. And also the 316 stainless steel is what is being used as replacement bolts. And that allows for a little additional preloading, which could be a factor in the failures in the other cases. In other words, when the preload was lost on the 347 bolts, then you get thermal and flow-induced fatigue type things creeping in there and probably contributing to the failures. Again, even though there were some more significant numbers of cracking in these bolts, we did not determine that this was a significant safety issue, and it's really because of the inherent margin. Like I said, there were, in the 700 to over 1,000 range of bolts in each one of these assemblies, and also you really the accident or condition that would cause these bolts to be challenged would be, again, a severe earthquake beyond almost the design basis of the plant, or also a large loss of coolant accident, which basically is a large attached pipe to the reactor breaking off and causing some jetting forces. And that, again, very low probability of those initiating events happening. So again, not a significant safety challenge, but certainly the unexpected nature of the number is called into question. Are we looking for the right things, and are we on top of this issue? So what the industry has done and what the NRC has done, immediate corrective actions for the plants that discovered this obviously were to replace bolts. And in some cases, the plant will also choose to not only replace the bolts that have failed, but take an additional population of bolts and replace them in a pattern that will avoid this clustering phenomenon that I mentioned. And it's really based on again, projected future degradation. So to ensure you're putting some margin in against that happening. The other thing, the industry was very prompt in putting together a Baffle-former bolt task group, or actually focus group, to look at several aspects with this. First, the inspection regime that we're using, the techniques, also to help with the procurement of bolts, and also the tooling for all this, because one thing I did not mention earlier, one of the challenges with this is the inspection of the bolts and any kind of replacement of the bolts is done underwater, because the reactor components, although the fuel is removed, all the reactor components are highly been highly irradiated, so there's a significant dose field from it, so the water is the shielding, and so developing tools and probes and cameras that can do this work somewhat remotely is part of the challenge with this. Other things that have happened is again, the focus group met with the NRC in a public meeting last month to talk about the progress on these issues. The original equipment manufacturer issued, as I heard mentioned earlier, bulletins or safety letters. There's a nuclear safety advisory letter that the manufacturer put out that talked about this. Also, we've identified a subset of plants that are most susceptible to this problem, and it really has to do with, again, the bolt material and also the flow configuration in the reactor. So certain reactors are the ones that are the outliers with the 25% failure as opposed to the 1% and 2% failures that we've seen. So those plants were identified, and they've committed to do an inspection at the next opportunity. So when their next refueling outage comes, there'll be an inspection. And also with that, they've done evaluations to show they're acceptable for operation until they reach that next shutdown date. And those shutdowns will be occurring over the next year, starting this fall and into the fall of 2017. Again, the industry has been working closely with the NRC on this. Also, the plants that did find failures have sent bolts off for metallurgical analysis, and that'll take a while to have that completed. Again, dealing with very highly radioactive components there, so it's sent to a hot cell facility, and that work will be done. Again, there's some interim guidance for inspections that have come out that talk about moving up the inspections for the most susceptible plants to the next opportunity. The NRC will likely endorse that inspection guidance through a staff safety assessment, which is a typical process we would use for endorsing some of the industry programs. So again, there'll be some communication generically from the regulator. It's already occurred to some degree from the industry, and we'll be working with through the process of looking at our guidance that's out there, the regulatory guidance for aging management programs, and instituting the changes where we see they're necessary based on this new operating experience. Okay, and with that, I'll wrap up and look for questions later. Thank you.
All right, thanks. Thank you for inviting me, Bessie. I'm going to not talk about the activity that we've been in discussing with Bessie on some of these the topics that we are focused on today, but I am going to give a little bit of background about the Academies, what we do, who we are, and with the expectation that many of you will hopefully be engaged in the project that we're going to undertake, and we look forward to working with you on that. We are a long-standing organization here in D.C. We were formed in 1863 under President Lincoln. We are a congressionally chartered organization, and our directive was to provide input to the government so that it could make knowledgeable decisions in public policy. So that's been our focus for the last 150 years. We actually not only focus on government policy, we also provide input to the public in the goals of improving public understanding of science and technology, and we also promote those that actually engage in research. So those are our three cores. As I mentioned, it started out as the National Academy of Sciences. We have expanded in the last 150 years. In the 1960s, the National Academy of Engineering was formed, and then last year we formed a new academy, the National Academy of Medicine, which used to be known as the Institute of Medicine. It's now a full academy. So those are our three membership organizations. That last organization there, our form of NRC, the National Research Council, is actually the organization that does most of our projects. So it's the ones that produce the reports and does some of the other activities, with one notable exception, and I'll get to that in a second because it's actually important here. But in terms of our projects, and I'll be talking shortly about some of them also, these three academies, let's see if I can figure out which, these three academies are actually our go-tos for many of the folks that we're looking for experts to help us address those projects that we're involved in. We draw from the academies, but we actually draw outside the academies. Most of our projects have maybe a third to a half of their members from the academies, and then the remaining groups, the sources of experts, are either folks that are suggested by Academy members or staff or some of the boards that provide their expertise in drawing, putting together our groups. The one exception that I mentioned earlier that isn't in the National Research Council that does do some of these projects is the NAE Program Office. And they do many of the other activities. Of course, their focus is on engineering, and they do a lot of education and online activities. The Research Council has 7 program units. As I mentioned earlier, I'm with the National Materials and Manufacturing Board. I serve under the Division of Engineering and Physical Sciences. And so these are our resources, the boards, the academies for putting together the groups that do the studies. One of the things that I do want to stress is we're not an appropriation. We don't get our funds through appropriations. We're 501c3, and so all of our funding comes either from individual projects. We do have some institutional funding, and we also get some foundational funding. So that's essentially how we do our work. I'm going to briefly talk a little bit about these two organizations, and the two that are engaged in discussions with BSEE are the NAE Program Office and the NMMB, and I'm going to give you just a little bit of background about them, and then I'll talk about some of the activities that we engage in. Here is the mission statement for NAE. It's 2 components. One is the focus on the engineering profession, and they do a lot of activity that focuses on the engineering profession. The other aspect of it is drawing from the engineers that form the body of the NAE and provide that expertise and insights to projects that we undertake. And their council is some esteemed engineers and other folks. Marcia McNutt is actually involved in that. These provide oversights of the activities that NAE is involved in, and also provide long-term supervision and support for those projects. This is the board that I work for, the National Materials and Manufacturing Board. This is actually a fairly recent board. We used to have a separate board for materials and a separate board for manufacturing. And I think as this forum reflects, those two are very interconnected often. And so we combine those two boards, and here's the current set of board members. They provide a lot of the expertise that we draw from in putting together studies, supervising studies, and stewarding studies. And for the most part, we're both the NAE and Program Office and NMMB draw from both academia and business. The NAE is, of their 2,200 members or so, about half are in the business world. We're a little more academic based, but these are a number of people that are involved in manufacturing at all levels and also materials at all levels. Now I'm going to switch from who we are and talk a little bit about what we do. I've listed here, grouped here, 3 types of activities. If you've been engaged with the academies, you're probably most familiar with the consensus studies that's the top. Those are ad hoc studies, meaning that we put together a committee for the express purpose of dealing with addressing an issue, and I'll get into a little more detail later. And they actually come up with a series of consensus recommendations, sets of advice or sets of options that they provide to the sponsors and to those that would be interested. The other set of activities that's ongoing are convening activities. I'll mention workshops in a little more detail later, but we also have meetings of experts and focus sessions. And again, these are not consensus building, they're not recommendations, but they are opportunities to gather together experts to address specific issues. And then the boards and the roundtables are continuing activities and more resources for our projects than anything. So just a little more detail about the workshops. Typically, this is, as you would expect, either a conference or symposium. It's focused on a particular topic, and there are many purposes for doing these activities. One very well could be the workshop in and of itself is what the sponsor wants. They're interested in the gathering, interested in hearing the experts discuss and some of the results that come out of that are workshop reports or summaries. So these are actually written materials, and I've got a couple of examples I'll give you later that reflect what's going on. Other activities that we use these for are either planning for future studies or as input for consensus studies. So this would be an information gathering activity, multi-day activity that provides an opportunity for those from communities to engage with the committee that's conducting a study and actually discussing the issues with that committee. So these are the consensus studies, and I've put out a couple of bullets that give you a little more information about them. These are actually a lot of times come in from a sponsor where a government agency, and it could be state or federal agency, will come in and say, we have an issue that we need some advice on. And so we will sit down and discuss with that sponsor, develop the task, what we call a statement of task, or the charge that we'll give to the committee, and then we actually put together the volunteers. So we'll draw from those resources that I mentioned earlier to put together a committee of 15 to 18 folks who have the expertise to address the topics that are set forth in the statement of task. We evaluate very closely for conflicts of interest, so that's a key consideration for us. And then we gather a lot of information, and so we'll either gather it through workshops. We'll have 4 or 5 meetings of the committee where we'll gather information, and we'll go out on site visits. So we do a lot of effort to gather the information. And then once the information's publicly brought in, the deliberations take place in private. And that's one of the key considerations of these activities is that these are actually independent assessments and evaluations that end up producing consensus decisions on the questions that are raised. And then after the committee generates its report, we'll put together a second group of experts, and that group of experts will actually take that report and independently evaluate it. So they will take the statement of task, will ask themselves, okay, did this committee do its job, and are its findings and recommendations or its advice, is it well founded? And then once that's completed, we'll release the full report. So that's kind of, in a nutshell, the process that we go through. I've listed here a couple of summaries the NMB has put together fairly recently. Applying material state awareness to condition-based maintenance and system lifecycle management is one that just came out this year. Novel processes for advanced manufacturing. So you see, it's materials and manufacturing based. You'll notice that a lot of these are defense-related. We have very close ties to DoD's communities of science and technology programs, and so a lot of these activities actually are generated through a standing committee that we have, the Defense Materials Manufacturing and Infrastructure Standing Committee. And then finally, I've just listed a couple of recent reports that we've had. Probably the one closest to the current topic is a corrosion study that we came out with in 2009. But we've also done issues dealing with lightweight technology, again dealing with DoD-related materials, and then an optics and photonics. That's a little different from this topic, but it actually, one of its recommendations was to set up a national initiative, and the National Photonics Initiative came out of this report. Incidentally, all these reports and workshop summaries are available online, download for free at our National Academies Press. That's nap.edu. And I believe that's the last of mine. So look forward to your questions.
Good morning. My name is Jaime Zhang. I'm a staff scientist in Material Science Division at Lawrence Berkeley National Lab. I'm also an adjunct professor in Material Science Engineering at UC Berkeley. I'll speak with you about the project with BSEE, subsea boat performance and critical drill-through equipment fastener study. I would like to thank the opportunity to speak at this very important event. In this talk, I will introduce you our project, starting with the motivation and the research goals in this project, and our current progress and future work. In this morning, you have heard a lot of talks. We know it's very important to study the boat failure issues, and there's a need for an independent assessment of these critical drill-through equipment fasteners in offshore oil and gas operations. And this assessment includes identifying the fastener systems currently in use, including both offshore and onshore, domestic and globally, and evaluating the design, manufacture, installation, performance, maintenance, and inspection processes. Then we hope to identify the similarities and differences in the industrial standards and regulations. So in the LBL projects, there are two interconnecting components. The first is to review the industrial standard and do the gap analysis. And the second part is materials, the lab experiment, to study materials corrosion under subsea environment. In this, so the industrial standards, we know there are a lot of materials. So far, we have looked into over 220 materials items. The listed here are the materials, the standards. You can see the API, ASTM, ISO, military standards. These are the examples we have been looking through those standards. We're continually looking into more, add into more of this on this list. I don't see this. Somehow this material is not showing. Would you like to use my computer? I'm sorry about it. Just a second.
Okay, I do not have an aspiring career in stand-up comedy, so I'm not going to tell you any funny jokes. But while she's getting ready, I thought I would reiterate a couple of points rather than breaking. Doug thought we could use a break, but I feel like we might lose you forever if you break. Okay, so hang with us while we switch this out. So just to remind folks that the panel that's selected here has to do with, if you haven't picked up the themes, I'm just going to put it on a whiteboard here and basically spell it out, is that we have people from industry that we've been obviously, Eric set the tone and explained that we had been trying to engage with the industry for quite some time, and a lot of the people in the room have been a part of that activity. And hopefully, Trent, I'll have a couple of questions for you when we get to the Q&A piece of this to talk about how that's working within the committee structure. So I think that's really important, and thanks to Eric for presenting that. And as we move down with Jack, he's going to be a part of our interagency working group on this issue, which has a catchy name, IBAT. Okay, we really try with acronyms, and sometimes we swing and miss there. But with the IBAT, what we'll be doing is getting together and having some symposium. See, a couple of people got my joke. Come on now, Elena gets my humor. So we'll be having a meeting, and Brian will close and talk with you a little bit more about that and what we hope to accomplish with that. And then, Jim, you did an excellent job of skirting the issue about what we're actually doing, and he kind of laid out the structure that we're going to be taking. So you can read between the lines and kind of infer as to what we'll be doing with them. And then with Jaime, it looks like you're ready now?
Yes.
Okay, so I will leave you with this idea that sometimes people think there are too many cooks in a kitchen, and we disagree. Every one of these different groups brings a unique perspective from other industries or different scientific approaches that we can throw at this problem. It's a really big problem, which is why we're here to tackle it today. Here you go, Jaime. I'm going to pull your mic down. Make sure that we can hear you. Okay.
Thank you. Sorry about it. Now the slides are back. We have been looking into these standards, trying to identify and compare the different critical attributes for subsea boats, including materials specifications, such as hardness, yield strength, ultimate tensile strength, elongation. We also looked into procurement, and including heat treatment, coating, shear stress, fatigue life threading, corrosion treatment, installation, quality analysis control, in-service inspection, human factors. There are a lot of materials, a lot of parameters to compare, and these just some examples on the findings. For example, the hydrogen embrittlement for the hardness in the threshold, we identified some of the inconsistencies among different standards. For example, the ACE, NACE 175, ISO 15156 has the most strict regulations specific to soil service environment, and it has the maximum allowed hardness of 22 HRC, while the other parameters, the other standards give different numbers. For example, the Industrial Fasteners Institute says the susceptible fastener products have the specified hardness above 39 HRC. The NORSOC have the different number, and listed are different. The standard have different numbers. Just the examples. I won't read through the lines. As you see, the API 16F says the maximum hardness for primary loading carrying components shall not exceed 35 HRC. So we have identified a number of differences in this standard, and the list is more on the heat treatment. For example, this NACE 175 says all parent materials must undergo heat treatment, while the different standard ASTM F1941 says baking is not mandatory for fasteners with specified maximum hardness 39 HRC and below. So these just examples, and we can list going on many of these things we have found. This more the ASTM B633, and we also found, surprisingly, there are a limited number of standard address the sour service environment. So far we have this NACE 175, ISO 1515. I specify the petroleum, natural gas industry materials for use in H2S containing environment in oil and gas production. And they're listed of the how the identification of the sour the water containing at least 0.05 psi of H2OS, and there's items saying how to avoid this sulfide corrosion, improve the resistance materials, including the nitriding, and listed these different materials. So these just examples what we found. I would not be able to go through all the details. I will just, so far we have been working on the draft, continually putting more of the findings in these documents. We would have BSEE to review these documents before open to public. And the second part of our study is materials corrosion. We know this subsea environment, we need to consider the high pressure and the corrosive environment, including the chlorine, ions, and the sour condition, CO2, H2S. And we know there are a lot of studies on this total pressure, high pressure, and oxygen partial pressure, and temperature. All these different parameters influence the corrosion of the materials. And I give you a few examples. And the total pressure has significant impact on the material's corrosion rate. For example, increasing the pressure and different stainless steel, different materials has different response to the material, to the pressure. And here is the impedance measurement, the current response profile. You can see different with different materials. I will not go through the details, and here you can have more detailed information here. In general, a lot of materials, for example, the X60 pipeline steel material, increase the temperature, increase the pressure will introduce a higher corrosion rate. Another very important factor is the oxygen concentration. With increase the oxygen concentration in water, in the environment, the corrosion rate will increase. And I gave two examples here. The left is a cast iron. As you see, the corrosion rate measured by the rate of weight loss as a function of this oxygen concentration. We can see the oxygen concentration increases introduce significant increase of the corrosion rate. On the right side, and again, you see the trend on the low carbon steel, the oxygen partial pressure increase, oxygen concentration increase introduce the corrosion rate increase. And this is measured by the average penetration depth, centimeter per year. Another parameter is the temperature. The temperature increase the corrosion rate. Here the left shows the pitting potential increases with the temperature increase. And the right side shows the steel at different temperature. You can see the corrosion rate measured differently. So for our study, we look into the scale-down boats at different conditions, looking into the impact of the total pressure, oxygen partial pressure, and temperature. Here is a chart of our planned study. We look into the boats with different these coating materials at different conditions. So this second part of the study will form the second part of this report that will be published. So this work, we work closely with Argonne National Lab, and I have group members assist me for this project. Thank you for your attention.
Okay, so by my count, it's about 12:20, and I did promise that since we were running ahead of schedule, we wouldn't be here until 1:15. So I definitely have some questions and some follow-up. Thank you. There was going to be some sort of a horrible trip hazard that happened if that stayed here. I'm not so sure-footed here. So I definitely have some follow-up questions, but what I'd like to do is open it up to the audience first to see if anybody has any questions right now that they wanted to ask any one of the panelists, and if not, I'll get into some questions, and then if people feel comfortable, you can jump in. It's a very timid audience. There's a question here.
Just a brief comment, but maybe the gentleman from the Nuclear Regulatory Commission could maybe compare, the types of code standards and regulations that, let's say, the nuclear business would use, let's say, with an ASME code standard versus some of these other standards that are being shown today.
Okay, thank you. I'll take a crack at that. For the pressure retaining components in nuclear applications, it's the American Society of Mechanical Engineers ASME code, and there's a section 11 which is for nuclear in-service inspections. So that's kind of governs the majority of it. Again, there's construction codes under ASME as well, and then there are some reliance on certain ASTM standards as well for certain things. One thing that's interesting, again, with this bolting issue, obviously there's bolting that's in pressure systems, so that's kind of handled separately. These internal components, because they're not pressure boundary with the outside, again, a lot of that is covered by industry standards. Actually, this aging management program that I mentioned came out of the the Electric Power Research Institute, EPRI, was the sponsor, and there's a Materials Reliability Program, the MRP, that the nuclear utilities all participate in. So this MRP organization actually developed the aging management inspection regime that covers bolts and a lot of other materials that are not necessarily pressure boundary that would come under ASME. And the NRC endorses those, the MRP, the industry type standards, usually through a safety evaluation type of thing. And then the ASME code, which again governs the in-service inspection and construction, those are actually incorporated by reference in our regulations. So it kind of works a little differently depending on which component and application that you're looking at. So hopefully that answers the question.
Surely there are other questions in the back. It is helpful if you just say your name and your affiliation.
There you go. Sorry. I'll just start over again. Thank you so much for everyone speaking. My name is Ryan Ono. I work with Ocean Conservancy. I have two questions that are a little bit more scientific in nature, maybe for the two scientists who presented more scientific focused presentations. And the first one is, do any of you know whether these bolts or fittings have been tested at a range of pH values or salinities? And the reason why I ask is because chemists such as Dr. Frank Malero have proposed that ocean acidification could affect the speciation of metal ions in water, and that would have biological consequences. But we wonder whether progressively decreasing ocean pH values could affect the structural integrity of the bolts and have just any sort of impacts on the failure rate of metal alloys in these underwater structures.
If anybody from the panel and/or Candy wants to jump in to try and answer that. It's a very good question.
Yeah, this is a very good question. There are some studies, I'll just very brief, some studies, pH value indeed impact the material's properties. But currently there's no conclusion on that. Certainly there are a lot of needs to study for the consistent study, systematic study on this. That's
Excellent response, Jaime. To expound on that, just elaborating on what I mentioned earlier, that's something that should be explored in possibly the future research JIP, the impact on water salinity with regards to the corrosion degradation rate, the cathodic protection, and the material properties. So that's something to explore. I think I may or may not know where you're going. Are you implying microbial-induced corrosion, Mick? In regards to biology?
Not necessarily, just know that water, chemistry, there's a lot of
Okay, well, Mick is more like a sulfate-reducing type bacteria. They love iron, so in this instance, it may or may not impact, but that's one definitely for further study at this point. And as Jaime has mentioned, there's a little gap in the area. Well, not little, but it's one for further study.
Okay, other questions from anybody? So timid. See, I know that normally we get together with a group of, oh, excellent. Normally we get together with a group of people and everybody talks. So this is very, very different. Go ahead, Trent.
So we briefly, can I ask a question, I guess would be the first?
Yeah, absolutely.
You said to think about questions. So, you mentioned IBAT today. Is anyone from the U.S. Navy involved with that group? Because, as we're sitting here talking today, nuclear, although interesting, and space, although interesting, of all the government branches I can think of right now anyway, the most similar would be the Navy. And I I saw U.S. Navy standards come up on one of the slides. And so, you know, have you guys contacted them or had any conversations?
Yes.
Okay.
Yes. So the group right now, there was an initial invite, and we had an initial call, and Brian was actually going to talk about this a little bit more when he closes, so I won't steal all of his thunder. But to answer your question, we did have someone respond from the Navy, and we had numerous others. Now what we're doing right now is going to be firming up that more definitive list going forward. So yes, the Bolt Action Team. So yeah, they definitely were a part of the mix of invitees.
That's good.
Yep. There's a call over on the side, or call, hand.
Jenny Mandel, reporter with Energy Wire. Are there any indications, either from formal data collection or informal data collection at this point, that this problem is occurring in other countries' offshore drilling industry?
I don't know if anybody else wants to take that. Candy, do you want to take that?
We've received some data collection or data info sharing through IRF, the International Regulators Forum, through ANP in Brazil. So there's still information ongoing, and yes, we are reaching out. Thank you.
Yes, we're reaching out, or yes, there are indications that other countries see this?
I'm sorry, there's other what?
Was it yes, we're reaching out, or yes, there are indications that it's a more widespread problem?
It's a more widespread problem, and we're interested in gathering information and reaching out and so on. Yeah.
You're continuing to reach out.
So Brazil, I know our regional director contacted some of the other countries and told them about that incident that happened with the connector failure. And like I said in the slide, we had like 11,000 or close to 11,000 of those fasteners were recalled by the manufacturer. It did, you know, we only had 25 rigs affected in the Gulf of Mexico, but there was much larger number of rigs affected worldwide. And Brazil did respond back in one of the emails that Lars Herbst, which is our regional director, and they responded back that their largest operator, Petrobras, had reported 56 rigs on that incident were affected by that bolt, recall.
That's in large part a big reason why we tackled this issue, is thinking about the scope. The international nature of how rigs and mobile vessels come in and out of U.S. waters does make this something a bigger concern. So just because we would address it here doesn't mean that a rig or some other vessel could go to another country. Some part might be replaced using some other kind of bolting and then come back. So that is a concern in terms of the international piece. And that's a big part of why we started to talk about it. And as Brian Salerno, who's the chairman of the International Regulators Forum, he's brought it up in some of the meetings and discussions with the rest of the partners in that organization. Any question in the back?
Hi, Lem Hunter with Vibrant Corporation. Dr. McNutt talked about the safety profile in aviation, which is the industry that I'm from. We manage that two different ways. One are all the types of standards we were talking about here for production of new components and making sure that the initial quality is right. But aviation also has a tremendous amount of ongoing periodic inspection. I'm a little bit new to the undersea side of it. What are the current ongoing inspection requirements or activities with these bolted assemblies?
Trent, do you want to tackle that?
So it varies. One thing that is worth mentioning, Doug introduced us into subsea blow preventers. They are routinely brought up to surface for maintenance activity, so there's opportunities to inspect them at that time. So there are varying inspection methods that different companies utilize during those periodic maintenance activities when the BOP is on deck. There's a wide variety of inspection methods that are utilized. probably can't get into each one of them specifically, just it's a fairly long technical discussion, but the rig contractors do have a preventative maintenance system that inspects the bolts.
And from BSEE's side, Troy, do you want to comment on our requirement in terms of the BOP testing offshore? I'm putting you on the spot.
Well, I'm not sure what the process is with the industry, but I know every 5 years they're required to inspect that BOP stack and actually tear it down. And I thought that most of that bolts and fasteners and everything were just replaced at that time. Yeah, that's what I thought. Once they unbolted it, a new fastener was put in place. But I'm speaking out of turn here. That's what I thought happened, but I'd rather industry answer that question. But I believe that's exactly what happens. Those fasteners are replaced about every 5 years.
And we certainly have a number of industry people in the audience if anybody does want to chime in, although that's being brave. Other questions?
The 5-yearly requirement, we will inspect. We don't necessarily replace all the bolts. Many are replaced, but the requirement is to respect them. Sorry, I'm Pete Bennett with Pacific Drilling. Also, one point I would like to mention, I think when we refer to the bolt failure and the number of affected vessels, it's maybe been misunderstood, perhaps taken a little out of context, that this was because of the lack of traceability on the bolts. It wasn't all failures. It was simply that there was inadequate records on the heat treatment that the bolts had gone through with the coating.
And that's a really good point. I'm sorry, the light is like right where your face is. So on traceability, okay, so that's something that has come up in a lot of the various discussions, and I'm interested. That was one of the questions that I actually had. So thanks for teeing that up for me. I wanted to pose that to a couple people on the panel. I wanted to talk to first Jack. When you're looking in terms of your bolts that are being used in the baffles, what is the traceability that you guys have employed with the nuclear industry?
Okay, well, I guess in general, this would be the nuclear industry uses the safety-related label for, they call them basic components, and basically it's something that makes sure that the reactor can be, maintains the pressure boundary, make sure it can be shut down in accident conditions and keep it cooled, So these baffle bolts and other internals in a reactor would be subject to, basically regulatorily mandated quality assurance programs. There'd be a pretty rigorous QA program with it that the manufacturers would use. There'd be certified material test reports and traceability of materials through the manufacturing process. Also, the NRC has a vendor inspection program that will actually go out on a periodic basis to various manufacturers and vendors. And also, in the case of these bolts, when they're being installed at each facility, each nuclear facility has a inspection oversight. They're actually resident inspectors at the plants, and they're backed up by a regional office. So when an activity such as this bolt replacement comes up that's a little off normal, the region would inspect the activity, which would include an audit of the paperwork trail to trace the bolts, and also just a verification that the installation was being done appropriate in accordance with the procedures and everything. And they'll also utilize experts from the regional and headquarters office to back them up if there's something different. So it's a fairly rigorous process. And again, I think it starts with traceability of the material from the source before it ever gets installed in a plant.
Great. Now, Trent, would you like to speak maybe a little bit about what you guys had discussed in your committee? I think that's an issue that's come up.
Yeah, I mean, I think the short answer to that is in API 20E, there's 3 service levels that are identified, BSL level 1, 2, and 3, 3 being the most rigorous. For a BSL level 3 bolt, there's unique traceability to each bolt. And so, historically, the standards have varied. We talked a lot about a lot of the past standards. So historically, there were some standards that allowed batch type traceability, so you'd understand the material properties for a batch of bolts, maybe not traceable to each single bolt. Going forward in our proposal, we have API 20 spec bolts, and BSL level 3 is the recommendation for the critical bolts, and so we'd have that individual bolt traceability, and it would cover the same sorts of material, from the mill through the manufacturing process. All the key variables would be traceable and trackable.
Okay, that's great. Another question for the audience? Another question from the panel?
Yeah, just for Mr. Lancaster, I was curious as to when you move forward with your potential pending program, is that done through a formal announcement? If there's volunteers or public meetings, how is that announced?
Well, once it's approved, we'll make an announcement. The sponsor will make an announcement, and then the information gathering process for putting together the committee is kind of it's a process that we don't go from A to Z. We kind of go in a network type approach, and so we'll actually look to organizations. We'll look, of course, to the boards and the Academy members, the sponsors for potential members, and we will have expert areas that we're trying to fill for that committee based on the task, and so that's what we'll be looking for, is people to fill those expert fields. Sure.
Other questions? So, keeping an eye on time, we're doing pretty well. So I had a couple of things I thought I would put out for food for thought here. As I am hearing the NRC example, and I'm thinking about how you have a bolt there that's very fit for purpose, and they've really looked at all of the different worst-case scenario parameters for how that would operate in a baffle. Okay, so I feel like every part of a nuclear facility is pretty critical, because these are very, very, if not over-engineered systems, because while most of the events are low probability, they're extraordinarily high consequence activities, as you can see from the example of Fukushima, when one does fail. So now, when you take a look at what we're looking at, whereas here the NRC has under 50, how many facilities in the U.S.?
There are about 100 operating power.
Okay,
reactors.
well, I was way off. Okay, so about 100. So compare that. Anyone in the audience know right now how many facilities that we have on the outer continental shelf in the U.S.? Anybody? I'll give you a prize. What was that? So we have upwards of 3,000. All right. So discrete, different sorts of kinds of pieces of infrastructure offshore on the OCS. So, and those come in and out of waters, and that count does change. So when you think about that, every one of those is sort of unique, like a fingerprint or a snowflake to some regard. There are some standardizations, but as they come in and out and people move different parts, and some of them are older and some of them are younger, we don't have the tighter sort of maybe quality assurance or control over the broader offshore facility and all of the different components. Some of the component ratio is very, very high. Now, when you look at something like a blowout preventer, you'll have a few different kinds of blowout preventers, a few different kinds of connection devices, et cetera. So now we're narrowing it down, okay? But we still have several different vendors that we're talking about. Now, how many vendors do you have with the NRC that people can get your bolts from, for instance?
Well, actually, this is a real short list because, and again, if we're speaking just about this baffle
Sure,
bolt
or you
issue-
can speak more generally how the NRC works with it.
We'll do the bolts first because that's kind of simple. First off, there are two main types of reactors in the U.S. for power generation. There's the pressurized water reactors, which I talked about today, and there's also boiling water reactor, which is the General Electric technology.
Mm-hmm.
They don't have these bolts at all, so that drops the number from roughly 100 down into the 60s. And some of the of the pressurized waters, there's actually 3 manufacturers, and it's Westinghouse, Combustion Engineering, and Babcock and Wilcox. But now, over time, there's basically Westinghouse still has their technology, and also they cover the combustion plants. And then there's Areva, which deals with the Babcock and Wilcox technology, and they're also related to the French reactor. So really, you have a very short list of manufacturers or vendors for this, in the U.S. If taking the broader look of it, it's really General Electric, Westinghouse, Areva for the most part is being the original equipment manufacturer reps. So it's a short list.
So that was my point. We also have a short list too. So even though we have this broad range of different facilities and different types, as you get into the critical safety components here, we have a pretty short list of actual OEMs that are supplying these. And so when you keep that in mind, you look at an example like the NRC had today, that Jack had, in that they have very tight quality assurance. If we have a small vendor community that's working in this space as well, there shouldn't be any reason why we can't have a pretty tight handle on those as well. So one of my questions for Trent and Eric in particular is, how do you feel the industry is doing in terms of the uptake and application of your standards that you've used? And do you think people will readily adopt these? Because keep in mind, these are not mandatory at this point. These are industry standards, and they're not in the Code of Federal Regulations.
Yeah, I would say yes, and I think when we talk about the population, we have to recognize the difference between production facilities and drilling operations. So you have 3,000 production facilities and probably anywhere from 20 to 40 drilling rigs where you actually have a BOP involved. But the industry has taken a very proactive approach to this. We've involved not just API, but the other trade associations are aware of it. We're spreading the word, and we appreciate the opportunity to engage with BSEE so that we understand from you that these steps that we're taking are those types of steps that holistically should effectively address the issue. Now that we are moving down that road, we're going to start to have much more momentum behind the efforts to incorporate 20E, 20F, and others, because we want to make sure that that's understood as something that the regulator is accepting of.
So in general, would you feel that, as you've had your discussions within your committee, Trent, that people had been adhering to the existing standards?
Yeah, and so just, and Eric said it correctly earlier, 20E is a specification.
Okay.
There are API 20E spec bolts being manufactured and installed in BOPs operating in the Gulf of Mexico. So that work has begun, and as Eric said, as we begin kind of moving down that path, we'll be checking in with BSEE regularly to update them, as progress is made.
Okay, so down the road, I think the question has been asked to us over time in the last couple of months about what the impact is. So we've kind of heard from Troy and Candy and others about the global impact of the first bolt recall that had been done. Now, as you're talking about changing the specification, how do you guys propose, as a new specification is put out, that the industry actually go about replacing bolts? Because Troy had a nice slide up there where he showed the impact to each one of the facilities and how long that would take. So what is the proposal coming from API?
Well, that's the process we're going through right now, and you've seen it through the conversation today where companies have taken proactive steps. The original equipment manufacturers have taken steps to do recalls, and we are working with the manufacturers, the drilling contractors, and the operators who are part of that discussion, who are now operationalizing the steps that we've put forward. So it's happening as part of the normal business that this industry does to enhance safety, identify the issue, review the data, identify the steps to take, and start taking them. So the implementation is occurring. It's going to continue to occur, and it's just through the industry networks that we have and through the conversations that the industry has with the regulator and communicating the significance of the issue.
Do we have any follow-up on this thread of discussion so far? Okay. So I have a couple more questions, and then we'll close here. Thank you for that answer. I wanted to shift over to Jaime very quickly. Thank you for your presentation. I hadn't heard the results of any of that yet, so that was pretty exciting for me. And it looks like you guys are doing really great work. So I think I'm not the only person in the room who wants to know how much longer the rest of your study is going to take, and then what process, maybe this part's for Joe, what will happen after that research is conveyed back to BSEE? Is it going to go out for peer review, or how is that going to be handled? So if you could just very quickly describe how close you guys are finishing to close to finishing the rest of the project.
So this project started January. We've been into the project for 9 months. It's in the middle of the project.
Okay.
Over another, we have total 21 months.
Mm-hmm.
Still have, in the middle of the project.
Okay.
For the procedure after we have the report, we've been have the ongoing teleconference weekly, bi-weekly. We have monthly report going on with BSEE. And after we have the report, would we have the review process? And that
Yeah, I believe the project is scheduled to be completed. I believe the project's scheduled to be completed December 17, so year and 5 months from now. Allison mentioned peer review. BSEE has a process for peer review of select research projects. We look at all the different research that we're currently doing, and we pick for independent outside the agency peer review on select projects. Within Doug's shop, ORP, we've only recently implemented this process. We have the first peer review underway, nearly completed. So I couldn't say whether we would peer review this LBNL or not. There is a significant difference. The peer review we currently have is our TAP project, right? This is LBNL is via the ANL DOE interagency agreement. So, but it's a good idea, and we do have a process in place to peer review. Yes.
I'm not sure everybody realizes that we do utilize peer review at BSEE, so it was a little bit of shameless promotion there. Thank you.
It's a new program. So.
A couple more questions. Anybody else from the audience? Oh, there are some. Okay, so I will start with this gentleman, and then we'll go back to Lisa in the back. Okay.
Hi, I'm Satya. I'm from ABS. My question is about the testing on the. From the discussion today, it is apparent that most of the failure mechanisms are hydrogen embrittlement related. So is there any testing associated to understand those mechanisms at your laboratories, Dr. Zhang?
So the hydrogen embrittlement that you have seen mostly from the industrial standard review, there are quite a few number of the reports. There are a lot of studies on that. We found there are very limited study on materials corrosion testing under subsea environment. So we are focusing on corrosion study on those different parameters, pressure, high pressure, corrosive environment, chlorine, different ions, oxygen partial pressure, and temperature impact on the corrosion rate.
Okay, so Lisa had a question in the back.
Good afternoon. I'm Lisa Sally from API, and I actually have a comment and then a question. Just more of a comment and food for thought. Just with the study and the research that won't be available until December 2017, if possible, it would be helpful to see some of the interim analysis, if there was a willingness to share it in general for us. We'd like to talk about that. I also want to commend BSEE for the foresight to conduct that study, and we look forward to engaging as that information is available and for the industry to review and for consideration in our future documents. So that's my first comment. My question really centers around an attempt to distinguish between, I'm going to say, forensics and life study and understanding of bolts separately from the operating conditions and the environment of the subsea environment. And so I just want to generally ask the panel, and for Betsy in particular, is there a body of work that's been done to understand, if you will, the forensics of bolts, when they fail, what contributes to that, and the variables associated with that? Has that body of work been isolated thus far?
So I would direct that to either Joe or Doug, if either one of you want to tackle that, because some work has been done.
Yeah, that's a good question. I'm no expert in this area, but from what I've seen, we see the forensics on like a case-by-case basis as a failure is reported to BSEE or to a company. They typically do an RCA at a lab. I'm not going to name the labs, but there's several in Houston that can do this work. Actually, industry, the operators may be privy to more forensic info because, I'm not confident BSEE has all the, failure data. So I don't think there is a body of evidence. It's a case by case, to my knowledge, depending on the failure. And while I have the mic, just so I can say this with the mic, and this is to Jack, you said there's like 3 bolting vendors for nuclear, right?
Well, I won't say that. 3 reactor vendors. So
3 reactor.
Right. So they're going to get the bolts from various sub-suppliers.
I
don't know that number.
Is what I've seen, like in the subsea BOP offshore oil and gas world, these connectors, it goes from one OEM, and Candy mentioned it at her talk, and then we see second and third and fourth tier OEM subcontracted out for all different aspects of the bolting manufacturing process. So it's a hard nut to oversee. I wonder, is the nuclear bolting manufacturing process set up that way, or do you have one OEM that can do the whole thing from soup to nuts, or do they have to go out to many other companies?
Actually, I'm not that sure that not being that close to the process, I really don't have I don't want to take a guess at it. Again, I know the reactor vendors have their sub-suppliers for different components, but again, how splintered it gets, especially in the bolting area, I don't really want to hazard a guess at that. So.
Sorry. Thanks.
Certainly a good question that we could pose to our interagency group too for more discussion. So as promised, I said I wouldn't keep us until the last bit of time, although I did see, I think there was a couple other questions in the back. Can we hang in there for 5 more minutes? 2 more questions, and then we'll round up with Brian Salerno. Yes, go ahead.
Tim Fakey from NIST again. There is a body of work on fastener quality that was generated in the late 80s and 90s and onward that was required by the National Fastener Quality Act, which is something that people should be looking into if they want some background on fastener work in the past.
And I have to say it, as a mechanical PE, we had to study that for months after months after months in school. And so, yeah, there's a lot of data out there on fasteners and whatnot. Question on the quality of the fasteners that you've had issues reported with. Are they all BSL 3s, or are there 2s in there as well?
So far, most of those failures predated the use of bolts that were made to that spec. So I'm not aware of any failures with an API 20 BSL level, actually of any 3 of the levels.
Okay, any other questions? I should say thank you to the gentleman for NIST. NIST is actively part of our interagency working group as well. Going forward, we had invited them to participate, so thanks for joining us. Yeah, sure. It's Troy Trostman.
So one of our regs require for any well that's being drilled, we require a third party to come in and say that that BOP stack is fit for purpose. Now that's a lot on that third party, because it's everything associated with that BOP stack, which includes these fasteners. Now, the only time we've ever looked at fasteners was that first event that happened in 2012, and we actually asked for certificates of compliance with that specification that was given on that particular fastener. And so before we would let the company go back to operation, we looked at those certificates of compliance. I'm not saying we do that right now. We look at that overall BOP fit, it's fit for purpose. When we see that, we assume ABS, or DNV, Subsea Solutions, whoever it is that did that third-party certification, we're assuming they looked at all that specification stuff. They're saying it's fit for purpose. It's probably a bad assumption on our part, maybe, but that's what we're looking at as far as, yeah, it's been certified by somebody that everything on that stack is fit for purpose. So.
And certainly that'll be another place that we'll be discussing going forward as we're working on this topic of bolts. So, so with that, I have one or two things left, and we're going to turn over to Brian. If you haven't seen already, we actually have some bolts / there's debate, bolts or studs, you tell me, but bolts over here on the table, so you can take a look at that if you've never actually seen the scale that we're talking about. So please go and check those out at the end. And then the other thing I want to say is rarely does an event like this happen without a village of people who are very exceptional at their job. So I'd like to thank BSEE's Office of Public Affairs for hosting and putting this event on. When this came up, we identified a need, and the team came and delivered a very professional event. So thanks to them. So first, let's thank our panelists. Thank you, panelists, for coming. And thanks to the Public Affairs team as well. Thank you. And with that, I'm going to turn it over to Brian Salerno to close.
Okay, well, thanks, Allison. Well, this has been a phenomenal discussion. Great presentations. I do want to add my thanks to all the panelists today for really helping to frame the issues and help us map our way forward. You know, when we started this morning and we had the presentation by Dr. McNutt, you know, she said a lot of really useful things, but even just the title of her presentation, Failure is Not an Option, I think is one that's particularly germane to this discussion. She made some analogies there which were quite powerful. You know, the O-ring analogy on the Space Shuttle Challenger, a simple component, but that failure had a catastrophic consequence. Doesn't take much to see how we could face a similar thing if we don't tackle this problem. Janice Schneider hit on something too which I think is worth calling out. When she was talking about the company CEO that had mentioned that they had a number of BOP poles to replace connectors, it really kind of underscored the fact that this information there's awareness at a company level, but it's been very compartmentalized. And part of our challenge is to bring that information out into the open and share it so that we have a fuller appreciation of, hey, this really is something we have to tackle as an industry, which I think is the overarching theme of why this forum is here, why we're engaging in this discussion going forward. I think our panels did a great job framing the discussion. I think the first panel indicated a number of areas of concern, four in particular: design standards, manufacturing processes, QA, QC, operational procedures. And although many of our other speakers had maybe different ways of framing it, I think a lot of those themes kind of were consistent. You know, those are the kinds of things that we needed to focus on. And then, of course, in our second panel, we had a more in-depth discussion on critical knowledge gaps and what we might be looking towards as a way forward. Eric Melito, I think, did a great job just underscoring how, this isn't the first discussion we've had. A lot of work has already been undertaken by the industry, good steps forward. We're really, I think, quite pleased with that reaction. And again, he has a number of focus areas that they've identified, such as standards, QA, QC, research, again, which resonate, I think, with some of our first panel discussions. Jack McHale with the NRC, talking about the types of connector issues in the baffles and the reactors. Again, different issues. I mean, offshore, we don't have to worry about irradiated systems too much, but the QA part of this and just how we assess risk, I think is very relevant. And so we look forward to continuing that discussion with Jack. Jim Lancaster, we're definitely not done with you. We are really looking for a very robust involvement with the National Academy and with NAE in particular as we go forward here. And Dr. Jaime Sheng, the work that you're doing is of great interest to us. The effects of corrosion and your gap analysis, I think, are right in line with the kinds of questions we need to answer. I think all this really boils down to the fact that we have general awareness that this is a pretty broad problem. It's very difficult right now to define the scope. I've had a few sidebar discussions during the morning about, well, what's the answer going to be? And I don't think we know the answer. We can't quite jump to the answer until we've fully defined the problem. But one thing that I believe we all share is that sense of urgency. We've got to get to the answer in fairly short order. So where we go from here? The IBAT, our team, we are looking to convene that group mid-September, say second or third week of September. We're looking maybe to set up an in-person group meeting where we can further explore some of the issues that were raised today. And we'll keep the momentum going, and we'll keep at it until we get some solutions. So with that, again, I want to thank all of our panelists, all our speakers, and I want to thank everybody from the audience who, first of all, came and stayed with this program and asked some very probing and engaging questions. I think that was all very helpful and contributed to, I think, a very illuminating morning for us. So with that, I'll thank you and look forward to seeing you again soon, and please stay engaged on this.